We are going to talk about Docker and container. And to understand what is Docker and what are containers, we need to go and see the virtualization structure first. Only then we could able to make sense or would able to understand Docker and container well. So as you can see on my screen, in the traditional way of virtualization, we have the first layer of hardware, then we have our host, then it is the layer of virtualization like hypervisor, any kind, okay? And after that, we create the virtual machine, which has their own operating system, and on that, we run the applications, right? That's how it is. We all know that. But in case of the Docker and container, instead of hypervisor, we have container engine. And this container engine would give the capabilities to these containers to run in an independent environment which has all the required libraries and binaries. But to run this, they can share the host kernel. Okay, if you talk about the traditional way, they are on kernel mode isolation. Like every VM has their own kernel, every VM has their own CPU, memory, and everything. But in case of this architecture, they abstract from the underlying host. Okay, so it is a kernel mode isolation and it is a user mode isolation, and that is the reason these containers is fast as compared to virtual machine. Okay, and each of the container has all the required binaries and libraries to run the applications. I should right here there is a app running. Okay, similarly we have apps running here, here, and here, but here they're running in their own operating systems, which is abstracting all the CPU memory from the below host. You have to give at least 1 GB of RAM to run this operating system. It is not like that in the containers, right? So if we talk about what is actually a few differences between containers and virtual machine, this architecture will help you understand. As I said, whenever we reboot a machine, okay, it takes time because it has their own operating system. First operating system would go up and then the application start working. But in the case of containers, it is not like that because containers are fast and boots quickly as it uses host operating system to share the relevant libraries. Okay. All right. Now, there is one more thing that we can say. Containers do not waste or block host resources, unlike virtual machines, because they need amount of compute power to run a virtual machine. But it doesn't mean that the application need that much of compute power. So of course there is a wastage of compute power, but not in the case of containers. Okay. Now, this container engine is something which is required to run a container, and in this case, this container engine is Docker. Okay, so Docker is this layer. It's a Docker engine, and there are a few more available in the market, like a Rocket and other, but Docker is the most used one. So if I have to say what is Docker, well, Docker is a containerization platform that packages your application and all its dependencies together in the form of Docker container to ensure that your application works seamlessly in your environment. See, in this box, I have right like lib and bin. That means all the libraries and binaries to run this particular applications are there in this container. You can take it from there and you can run it anywhere else. It is like that. You don't need anything else apart from Docker engine to run this container. Okay, now let me explain you with this example. This will help you understand better. Let's suppose there's a developer who is trying to create this application of software. Let's take an example of .NET application with the help of Visual Studio. This developer is working. So as per the condition, it seems this application is more like you need to run it in the Windows, and it might not be compatible with Linux and Mac. Okay, so in that scenario, what I was talking here, we can put this application inside the container which has all the necessary or required libraries and binaries, and you can deploy this container in any of the operating system and it will work as it is. Okay, because it is running through a container. So it will help you everywhere and it will solve a lot of problem of development and operations as well. Okay, and I'm pretty sure you guys are already aware what Docker is and how it is happening, what is the architecture. That is the only reason, but I have to start my series with a little overview. So I have this thing for you guys. Trying to make a little, beginner's kick. All right, so this is a little architecture that I have tried to create for you guys, and here it defines the Docker is actually a client server architecture. Okay, and it has three components, as you can see. Client, uh, in what sense, I'll go through this later, but let me try to explain the three components of Docker engine because it's a client server architecture. The first one is server. It is the Docker daemon. Okay, it can create and manage the Docker images, and a REST API, it is used to instruct Docker daemon what to do. So, and the third one is command line. Client give commands on the command line. It talks to the API and instruct daemon to do as the command says. A very small client server architecture. But this is the Docker life cycle, you can say. In this life cycle, to understand this life cycle, let's go through some of the things first. Okay, like images, like container, like Docker registry. Okay, so client is like you and me who's working on the interacting with the Docker. Okay, with the help of command line. Docker registry is the hub where all the open source images are stored to use. You can have your private as well, just like GitHub. Images is something like, for example, this I told you, every container has its own, every application which is running inside the container has its all the required libraries and binaries. So if you want to capture this, it would become a template that is known as image. And if you run that image, it becomes a container. Okay, it's very simple. Image just a template of all the applications. If you run it, it becomes a container, and container can be running, can be stopped or deleted. So what actually happens, client like you and me working on Docker, we run the command like pull. It pulls the image from the Docker registry. Who pulls it? Docker daemon pulls it from the hub, and you get the image in your local host. Then you run it, it becomes a container. Maybe in a running state, you can stop it and delete it. Or if you want to change, you can change in the image, you can add few things and create another image out of this existing one and push it to the Docker registry for the use, or maybe to distribute to other people of your company, maybe. So this is a little overview of the Docker and container. In next videos, we'll try to understand the installation on Windows and Linux, and step by step, we'll try to cover all the container related topics. So thank you for watching, and you have a good day.